So if we're trying to get conversion factors out of the first sentence, as what we learned before, so it says that 8.5% MnNaOH. How can think about it? How can we write conversion factors out of this? So, so it's 8.5, 50% M slash M. Is it NaOH or what was the solution? NaOH. If we think about it and how to do it, we can say that we can also say that, so it's N and M. So we can say 8, and again the solubility, solute over solution. So we can say 8.50 mass gram NaOH were dissolved in 100 grams of solution. Or the opposite. 100 grams solution on 8.50 grams NaOH. Okay. And of course, I'm planning to give you problems so you can work on it, but just I'm giving introduction so far. 575% VV ethanol. We can say that 5.75 V mLs ethanol divided by 100 mLs solution. Here we can say, so here is, or the opposite. So we can say 5.75 ml ethanols over solution, or 100 mLs of solution over ethanol. Here we can say this is mass, which is grams and mLs volume. So we can say that 4.8 grams of HCl over 100 mLs solution, or the opposite. Okay, so whenever you have, they give you in an equation that it's the concentration of a solution is 8.50%, or they can say the mass percent, or the volume percent, or mass to volume percent, this number, then you can actually set up your conversion factors where you can use it. So those are, so again, if we go to the solubility table that we discussed at the beginning, here we said that the solute can be in grams, solution in gram, mils and mils, grams and mils, and then we have mole and liter. So we discussed all three of these, which is M and M, V and V, M and V, but also we have a capital M, which means a molarity. So molarity is the mole of solute over a liter. So here, the molarity, mole of solute over a liter of solution. So moles of solute over a liter of solution equal capital N. And if they give you a solution says a 1 molar solution of NaCl is defined as 1 mole NaCl divided by 1 liter solution. Okay. But what is the difference between molality from the mole and molarity that we're discussing now? So mole again is the measurement of the number of substance. Molarity is a measurement of the concentration. So mole is a unit. Molarity is not a unit. It's 2 units divided by each other. So we have mass over liter. So molarity gives you an idea of the amount of substances present in the solution and a mixture. molarity is given as moles of substance in one volume of solvent, which is 1 liter. For example, how to prepare a 1 molar potassium sulfate solution. So I can ask you prepare 1 mole potassium sulfate solution. So try to think about it, considering that again, molarity is mole per liter. So think about it, pause the video and think about it and come back to the video to check your answers. So basically you're looking for molarity, which mole per liter. So you can get mole of the solute, which in this case potassium sulfate, dissolve it in 1 liter, and then you will get the concentration of 1 mole per liter, which is the molarity. How can we get the mole? We have to go to the periodic table to determine this potassium and the sulfate, and then we a molar mass, and then we add them together, and we will get this number. And then after get this number, we'll divide it by liter, which will be the same number, and that's how we can prepare a 1 molar or a 1 mole solution. What is the molarity of 0.5 liter of NaOH solution if it contains 6 grams of NaOH? So they're asking about molarity. So basically they want the mole of NaOH over 1 liter. Okay. So here it says, but we need the molar mass of the NaCl, of NaOH, sorry. So we can say that 1 mole of NaOH equals 40 grams NaOH. And then we will have 2 conversion factors. And then we have 6 grams from the input here. So we would be using this conversion factor to get 0.50 mole NaOH. We got the mole now, and we have the liters here, so we'll divide the mole over the liter to get 0.3 mole of NaCl concentration, molarity. Again, what is the molarity of Na? Sorry. Let's see here. How can we do this one? Here. So, okay. Okay. So it says here, so given, back to the old method, given is 0.225 liter solution. And then here needed, we have here molarity, which is equal to moles over liter. So we also have here 34.8 grams KNO3. What we're missing now, so we have the liters, but we're missing the moles. So we can actually figure out the molarity. So we're missing the moles of KNO3. To figure out the moles, what we need to do is figuring out the molar mass of KNO3. So the molar mass of KNO3 will be, I can just go get it from here. So it's 101.11. 101.11 grams KNO3. You can say 1 mole is equal, okay, So we can have two conversion factors from this equation here. 1 mole over 101 to 11 grams KNO3 or 101 grams KNO3 over 1 mole. And then we have here 0.225 mole. No, we have 34 grams. So we have 34.8 grams KNO3, and we need grams to be to the bottom, divided multiplied by 1 mole KNO3 divided by 101 11 grams KNO3. And then grams KNO3 goes grams KNO3, and then you will have here, this is what you will get, 0.344 moles. I haven't finished yet. We still need to calculate this or turn them to liters. So we'll divide them, and then we have 1.53 mole solution of the solution KNO3. So this is how we can figure out the conversion factors of any solution. If the percent concentration is used, so we can get conversion factor out of here. We can say that 10 grams of KLCO is dissolved in 100 grams of solution, or mLs per mLs, or per 100 mLs, or 5 grams of 100 mLs, or moles per liter. Okay, so this is another example where it's asking you how many grams of NaOH are needed to prepare 75 grams of 14% NaOH solution. So our given is 75 grams of 14 solution, and then we need grams of NaOH. They also give us the M&M percentage, mass percentage, so we can get a conversion factors from here, and then so 14 grams of NaOH dissolved in 100 grams of solution. So we can have these conversion factors, and we have this amount of grams, so we can cancel gram of solution to get 10 grams of NaOH. Another example, how many grams again are needed to prepare this amount of this molar of the solution? So molarity of the solution means moles over grams. So we can have moles over liters. So we can say that 0.50 moles of this AlCl3 dissolved in 1 liter of the solution. And then this is the equality, and those are the two conversion factors. And then we do have 125 mLs of the solution, so we can figure out the AlCl3. So this is the first conversion factor here, and then we will, well, so this section here, we will stop here, and then we will find out the moles of solution. And then the second step is to get the grams of the AlCl3. To get the grams, we have to have the mass number and add them together to find the molar mass, and then we have an equality like this, and then 2 conversion. For the same concept,